Hello guys, welcome to another session. In this session, we are going to look into tools to convert from requirement to program. So far, we have seen that following things. So far we have seen Python overview, Python programming core concept, where we have discussed about data type, collection type, and various details about Python. Then we have seen that flow control in Python. Then in the last section, we have seen about the iteration and looping concept. Now this session is going to be more of theoretical session because from this session onwards you are going to write a program in a structured manner, so that you need a tool which will help us convert the requirement into a program. So these are the tools which falls into system analysis and design method. So let's look into the tools, which will help us to design a requirement into a program. So basically these are the tools which we are going to use whenever we are writing a program. For example, suppose you get a requirement. That requirement you want to convert into program. So we have to first decompose into functions. So prior to introducing functions in the next session, I wanted to introduce all this thing so that whenever you will write a program, you will thought of it as a functions. So what it means, let's look into an example. For example, if we are talking about one of the tool called functional decomposition, so what does it mean? Suppose if you are going to design a system for credit card applications. Credit card application is based upon various functions. So when we write program, we will not write the entire program in a one go. We will chunk that program into a smaller pieces, and those pieces we will write it in any of the programming language. This is applicable. So for example, if you are writing credit card application, that means it contains following functions. Just a demonstration purpose, I have used only these number of functions. For example, if you are writing a program, then it contains submit application function, it contains review application, it contains issue credit card. Review application is also containing two different functions, that is for check data provided and review for compliance. Review for compliance is also further chunked into two functions, perform credit check and review against internal rules. So this is the way you can decompose the functionality into different functions. When we learn functions, it is quite easy to write program when we are writing it into a functional structure. So here the question comes that why do we convert it into a functional decomposition structure? So the reason behind is that it is really very easy to understand by other developers. If any other developer is working with you, it is really very good while testing, and it ensures that it does what it is intended for. This is one of the reasons. Then another reason is that it should be maintained easily in case if any changes coming into the system, then it can be easily go along with the existing program. Another important thing, which is very important reason to convert the program into functional decomposition, is that it is easy to debug if any error we will get. So now we understand that why it is good to have a program into functional decomposed form. Now let's look into the terminology. You should remember these terminology when we are writing the functions. What are these terminology? The terminology is functions. So what does it mean? This is a task that is performed by a process. So you just remember it. Another term is decomposition. This is the process by which higher level processes, or say higher level function, broken down into lower level function, where each function represents part of the functionality of the higher level function. Now another term here we are getting is the higher level function. So what does it mean? So basically this is a function that has one or more sub functions that depends on the functionality of the lower level function for its behavior. So now this will give us a further term called sub function. So what it means? This is a function that provides some of the behavior of the higher level function. So let's look into example. So here the review application is further divided into sub-function. So that means it is a higher level review application is a higher level function. Check data provided, review for compliance is a sub-function. And the last unit is the basic function. If you look into that, perform credit check, it doesn't contain any of the further sub-function. So that means it is the basic function and it provides some functionality within the program. So these are the terminology you should remember. Now we understand that functional decomposition. We will move further and look into other tool. So what is the other tool we have? We have functional flow. So let's look into that, what it is. So functional flow basically deals about the data flows between the functions when they are invoked. So let's look into that. What are the things given in the functional flow? So basically we have three types of functional flow capturing tool. So these are the pseudocode. We need to write a pseudo program or algorithm steps, we can say that, which will describe that whenever any function is being invoked, so what will happen, and once that function execution is being completed, then what will be the next step, any other function need to be invoked, so such thing it will help us to design it. So the tools which is going to use in that is pseudocode, data flow diagram and the sequence diagram. So these are the tools which help us to designing the end-to-end aspect of a program, where we will convert into functional decomposition. We will define that okay, how many number of functions we are going to have, and then afterward it will be decided upon when how this function is being arranged sequentially, so that it will give us the information for which it is being designed. So now we have understand that pseudocode. If you haven't understand it, so in short I will tell that pseudocode we will use prior to writing any program. We will first convert it into a algorithm where we will write the steps, what are the steps a program will perform, and then we will write it into a functions. Now moving further, we will look into data flow diagram. So what does data flow diagram consist? A data flow diagram consists of set of input, output, processes means functions, functional flow, data stores, and the terminators. So let's look into an example of data flow diagram. How does data flow diagram look like? So this is the example of data flow diagram of a calculator. Here we are designing a calculator, and what does this diagram look like? So DFD will look like something like this. So let's understand this diagram first. So in this diagram, the hierarchy of data flow diagram is indicated by levels. See here, which expands on how the function in previous level is implemented by the functions at the next level. So basically friends, data flow diagram only presents the data flow of the situations where user selects some functions. So what will happen in this scenario? It is representing that the user has selected an add operation in a calculator, and for that it has to enter number, the two numbers, the first number and the second number at the level 2, and then the further processing will happen. So what will happen if any programs get executed? So this is the example of a calculator. Calculators one of the operations called add. When user interact with calculator, what will happen in the level 0, what will happen, and when it is moving further the same functionality, so it has expanded that if user selected the add operation, then what will happen at the level 2. It has shown that when further the program will get executed further, so then what will happen at the level 2. So this is the way we can represent the flow of the functionality of a program, and then further we will write it these diagram into a programs. So this is one of the way by which you can convert your client requirement into programs. Now let's jump back. So after that we will also have a something called sequence diagram. This is again another tool which help us to convert a program from requirement. Now moving further, so we have seen here that data flow diagram. Now we will look into flowcharts. This is one of the important component or tool to convert requirement into programs. So flowchart basically used to convert a requirement into a program. So there are certain notations we should remember that whenever we are reading a flowchart, so such notation you will come to know about that. So let's look into what are those notation is. So basically, so these are the notations you should remember, that how the process is get started, how we are representing the terminal like a start and a stop of the program, what will happen. So it is represented by a start, then the processes is represented by a square bracket. If any decision is coming into the program, then that is being represented with this diamond shaped box. And when it is coming for any input output operation from users or from machine, then we will be representing that with this bracket, this parallelogram. And then afterwards we will be showing the flow of that thing with this arrow key. And if we have predefined processes, that is being represented with this box. If we want to represent any stored data, then we are going to use this symbol. And if we have long flow chart, then we will use this connector. That suppose if you are writing a or designing a flow chart that is going to be very big and that is not coming into a single page, then we will use this connector to represent that there is further definition of the program or definition of the flow chart is also exists there. So these are the notation you will get. So let's look into one of the example. At complete, how does it look like? So basically, if you look into that flowchart calculator, so here you will see that the start of the program is represented by this box. Then here the user input operation, input output, and then user select two numbers. It will decide the which of the task user has selected. So it is a decision operation over here. So if user selected add to number in the calculator, we are going to design this program. We are going to write the program for calculator, perform these four operations: add, subtract, multiply number, divide number. So these operations we will perform in our calculator, and we are going to convert the requirement from a program. So let's understand that this is the flow chart which help us to design our program. So basically here it is taking the decision whether a user has selected addition, subtraction or multiplication or division. If any of one of them is being selected, as per that the operations need to be performed by the program, and then afterwards it will print the output, and at the end it will stop it. So this is really very important. You should remember these notations when you are going to write your program. So prior to that, you have to convert the requirement into flowcharts so that it would be really easy to write any program. So this is very handy tool. You should remember it. So we are going to convert this flowchart into a program. When we learn about functions in the next section, then we will do this exercise. Now moving further, let's look into other tool called data dictionary. So another tool we will look into this aspect is that data dictionary. So data dictionary is another tool for structured analysis and design. So basically it stores the description of all the data flow diagram data elements. That is, it records details and definition of the data flow, and the data that is stored in data store, and the detail about the processes. And the structure of the data dictionary varies from project to project. Some project maintain the data dictionary within Excel spreadsheet. Some project store the information in some other third-party software like Samantha and all. So it varies from project to project. So this is what I wanted to explain you in this session. It is quite long session theoretically, but it is really important when we are designing or when we are going to write functions, then it comes very handy. So on this note, I am just stopping this session. See you in the next session. Bye bye.